Hey guys, we are to section 5 in geometry. Again, every now and then we have these videos. This is pretty useful stuff here at the beginning. So take an opportunity, pause, try this warm up. Once you guys get a second to try these, again, get them in your notes for the note check. Go ahead and unpause and watch the video and pause as needed. So first example here, you guys can see the answers. Again, we need to keep in mind that all of the interior angles of a triangle always need to add up to 180 degrees. So you'll use that fact to help you quite often in this class. So in section 5, we're measuring and constructing angles. We've talked a lot about segments and segment relationships. We learned the definition of a midpoint. We learned the definition of a bisector. We'll see some similar terms with angles today in class. So it seems like we have quite a few learning goals, but really they all kind of go together. So first of all, name, measure, and classify angles. More important notation. Again, some of us are still really struggling with how to do the segment things that we learned at the beginning of the year. This is more angle notation that you'll need to make sure you understand how to do correctly. Students will be able to identify congruent angles. Again, we should know what the word congruent means at this point, and then be able to use bisecting angles and addition postulates. And we already talked about segment addition postulate. Today we will see angle addition. I'm going to talk quickly, pause as needed. It might be best to pause, copy, and then listen. So first of all, an angle is made up of a couple different parts. The interior and exterior, as you can see in the shaded area below, the interior of the angle is between the rays. The exterior of the angle is on the outside. Again, the sides here are made up of rays, so you have ray AC and ray AB that are making up the sides of this angle. The vertex is the point where they meet. Again, the interior of this angle is where that one is. So make sure you understand what it means when it says sides and vertex. The angle 1 is in between the two sides of this angle. The other thing that's important to know how to do is how to name the angle. So in this one, and let's go ahead and go back to this, in order for us to name this angle, you can actually do it several ways. As long as there is not a line extended off. So if there was another line extended off of this, you could not do this one. But if there's not, you can call this simply angle A. Okay, so because that line isn't there, we can call this angle A. Another name we can give it, because the 1 is there, is we can call this angle 1. Now, if neither of those options are there, you can always name an angle using the vertices. So we start with the rays and we put the vertex in the middle. So we could call this ray CAB, because again, the A is in the middle, so we can go from C to A to B, and we should know we're talking about this angle. We could also call it BAC instead. Again, either way, the A needs to be in the middle of this angle so that I know that I'm talking about this part right there. Again, make sure you copy down that notation. This is the stuff that we miss. Okay, so naming the angles in this image. There's actually several angles. Now, none of them are going to be able to be angle M. So if you paused the video and you tried this already, angle M is a bad answer, because if I say angle M, I don't know if I'm talking about this angle, or the whole thing. So we have to be more specific when there's lots of angles here. We have, first of all, angle JMK. So that would be this angle right here in between there. We also have angle KML, so angle KML. And then lastly, we have the whole thing would be JML, angle JML. That's the 3 angles in this image. Go ahead, take a moment, try to name each of these angles 3 times. Pause the video. I'm going to have the answers up momentarily for you guys to see and check. Make sure you ask any questions when I'm back if you have them, or if you're watching this late, pause and come ask a question. So here's 3 ways. Again, it's not the only ways to answer a couple of those. Obviously, on number 2 and 3, you can actually name it 4 ways. Okay, so there are those ones. Again, keep in mind, we have our vertice in the middle. Where we have our vertex, we have that point in the middle. So where we have the vertex, that point's in the middle. The next thing we have here is our protractor postulate. It's simply saying, kind of like our ruler postulate, if we have two rays that form an angle, we can take one ray and subtract the value either on the inside or the outside from the other. So if I follow this 0 around, this angle is 140 degrees. Or if I look at 180 and I subtract the 40 where I stop, that's also 140 degrees. Again, you've seen these terms before. An angle that measures less than 90 is acute. An angle that measures 90 is right angle. Above 90 is obtuse. And maybe a new term to us, we have a straight line, is called a straight angle. It measures 180 degrees. Again, make sure you pause and get this in your notes. Okay, so if I'm measuring and then classifying the angles here in this example, GHK, again, it's important that we know what angle we're talking about. So if I go from G to H to K, I'm referring to the angle on the inside of that. So GHK is this angle right here. So for GHK, again, it's going to be easiest if I follow the outside and I get 120 degrees, and that's obtuse. Okay, so for JHL, I'll highlight it differently. So from J to H to L is this angle right here. So again, we can start at 0 and we can see that it goes to 90. So this one is 90 degrees, and that is a right angle. And lastly, we have angle LHK. So we go from L to H to K. That's just this angle right here. You can either do 90 minus 55, or you can do 125 minus 90. Either way, you get your answer is 45. 35, I'm sorry. Spacing off here. 35, and we get acute. So, again, take a moment, pause. I'm going to unhighlight or highlight and get these answers up for you here momentarily. So you can see there your answers. 145 is obtuse, 90 is right, and 55 is acute. Copying and constructing an angle. Again, if you guys want to read through that, pause that. We'll actually, let's do this. If you want to do this on a separate sheet of paper on your own with a compass and straight edge, and turn that in with your notes, that would be worth bonus points to you. But I need to see these markings as if you were doing it just like the book says. So construct them, construct two congruent angles just like it shows there. Read through the steps and how to do it. As long as you turn that in with your notes, that's worth a couple. Let's do quiz bonus points. Okay, so let's make that worth, let's say 2 quiz bonus points if you do that in your notes. Identifying congruent angles labeled in the quilt design. It says ADC is 140. So I'm going to go ahead and write that in. We have ADC is right there, 140. And then it says, what is the measure of EFG? Well, if I look at the number of arcs it has, it is the same. So it's also 140 degrees. Example 3 is monitoring progress. If you look at those arcs that are marked and then the angles that are next to them that are in question here, you can see that they're pretty clearly not the same measure. And not only that, one of them looks right and the other one looks obtuse. Now, you can't just assume if they had the marks that we want. So if they had arcs inside, no matter what, they're congruent, even if they don't look that way. Last couple things here. So we have angle addition postulate. You need to add this to your notes. Now, when we wrote down segment addition postulate, a key phrase that I said that will pop up all the time is part plus part equals whole. So just understand, I'm going to say that for either angle or segment addition postulate. You're still taking 2 parts and adding it up to a whole thing. So in this one, it gives us the sum of those 2 angles is 145 degrees. So what I need to do to set it up is I need to say LKM, so angle LKM, plus the other one, MKN, is equal to the whole thing, LKN. So 2x plus 10 plus 4x minus 3 is equal to 145. And then you just combine like terms. So 6x plus 7 equals 145. We subtract 7, we get 6x is equal to 138. We subtract the 6, or excuse me, not subtract, we divide the 6 to the other side, and we get x is equal to 23. Now, x equals 23 does not answer my question. It says find those two angles. So what I need to do now is take 23 and I need to plug it back in. So 23 times 2 plus 10 is 46, plus 10 is 56 for one of my answers. And then 4 times 23 minus 3. So 4 times 23, let's see, it will be 92. Minus 3 is 89. Again, check and make sure that these two add up to your total from the beginning. Again, take a moment and pause now. It says it's a straight angle and it says it's a right angle, so that should give you a clue as to what you should sum them up to. So take a moment, pause, try these. Now that you've had a second to try them, you can see the problems there. They're worked out. I set them equal to 180 and 90 respectfully. And then I plugged in my values. A lot of kids are having questions and a hard time. I've had several of you already at my seat asking, why is 29 not the answer? Why is 13 not the answer? Because that's not the question. Make sure you're reading the question. Bisecting angles, so last piece. Again, bisecting means the same thing as it does for segments. It means it's cutting it exactly in half. Whenever I have a bisector, I know that the two angles on the either side are going to be congruent. Again, it's showing you how to construct a bisector. What the heck, I'll make it an even 4 quiz bonus points if you want to do that one in the notes as well. Make sure you draw it out. As far as this one goes, it says QS bisects PQR, and then it says PQS is 24 is marked. It says find PQR. Now, I want to find the whole thing. I obviously hopefully know that this other side is 24 degrees. That means the whole thing is 48 degrees. Okay, the last one here, it's asking you to draw a straight angle. Make sure you draw a straight angle. That's a straight line that looks like this, M and P with M in the middle. Draw a segment NQ that bisects it, and then tell the length of those two congruent angles. So take a moment, pause, try it. After you've had some time, hopefully your image looks kind of like this. You have a straight angle, you have a bisector marking congruent arcs. Now, typically, if you see a 90-degree angle, you guys have seen this before, it will be a little red box. But when it tells you to mark them congruent, you're going to have those arcs there instead. Okay, so again, that's all we have. The assignment's posted. You guys should have plenty of time today and tomorrow to work on it. We'll have a quiz again on Friday. Thanks, you guys. Have a great day.